Right, good day, Mr. Simons here. Now here we're looking at inverse functions, lesson 7. And now we're giving you a parabola, but with the drawing and coordinates. Now you should know there's two ways we can test the drawing. Either we're going to give you two x-intercepts, or we're going to give you a turning point. In this one, we're looking at two x-intercepts. We're going to answer relative questions that will come from it. Alright, so number 1, they say determine the equation of parabola in the form f of x equal ax squared plus bx plus c. They've given me a drawing of the parabola. I have the coordinate 2, coordinate 4, and the coordinate 8. So you may remember 2 and 4 are touching the x-axis, so therefore they're called x-intercepts, and 8 is touching the y-axis, therefore it's called a y-intercept. So when we give you two x-intercepts and another point, we make use of the equation y equal a, x minus x1, x minus x2. My first coordinate there is 2 and 0. That one is 4 and 0, meaning y is 0 at that point. And that one is 0 and 8 because x is 0 there. So first we substitute my x-intercepts in. Remember, the x value always changes sign when I substitute it into equation. So from coordinate that's positive 2, it goes in as negative 2. That is positive 4, it goes in as negative 4. Right, then I sub in always my other point that's given. In this case it is 0 and 8. So this states that when x, there you see my x is 0, that my y value is 8. Right, negative 2 times negative 4 gives me positive 8a. Positive 8a equal then 8. 8 divided by 8 gives me 1. So my a value then front is 1. Substitute back. X minus 2, x minus 4. So x times x gives me x squared. Negative 2x, the two closest ones. The two outers, negative 4x. Negative 4x minus 2x gives me negative 6x. And for the last term, negative times negative, positive, 2 times 4, 8. So they have my equation for my parabola. Right, now we're going to answer questions. So this question starts with a drawing. You don't get the equation, you can't solve anything further. Ne? So very important you know how to find it. We generally test about 2 of the graphs. Problem number 2, they say rewrite this equation in the form y equal a, x minus p squared plus q. So from the previous example, we got y equal x squared minus 6x plus 8. So first we're going to determine the axis of symmetry, right? Equation for axis symmetry, x equal minus p over 2a. P is negative 6, so that becomes the negative 6. A is 1, there's an invisible 1 there, so that becomes 2 times 1. Positive 6 divided by 2, x equal 3. 3 is substituted back in the original equation. So that becomes f of 3, or y, equal 3 squared minus 6 times 3 plus 8. That gives me 9 minus 18, which gives me negative 9, plus 8 then gives me negative 1. So my turning point, P and Q, is simply 3 and minus 1 from what I've calculated, right? Now, we know the a value there is 1, so if I substitute back there, that a becomes 1. My p there, p is positive 3, so it must go in as negative 3. It must change from coordinates to there, my x, but my y simply stays the same, so there it becomes negative q, 1 for q value, right? So they found it is every odd occasion we want you to write it in a different format. So I hope you follow. I hope you enjoy what I've done. I hope you can see the color coordination. If you don't like the colors, I know some people find complaints for everything. Feel free to complain. Let it loose. Let it go, as they say. Hopefully you get peace and you get better in maths. Right, number 3, determine the new equation h of x. For f of x, if it's translated 1 unit up and reflected about the x-axis. So just looking at past papers, generally there will be 2 places where we will find a new equation or new coordinates. Alright, so we're moving up, so we're vertically translating in the y-axis. Reflection about the x-axis, so if I reflect about the x-axis, I can only change the y value because I'm using the x value. So I have the equation from the previous problem, f of x equal x minus 3 squared minus 1. If I reflect about the x-axis, you need to know xy tends to x negative y. So whatever y is, you see x-axis, x stays the same, y changes sign. So there, my y value is f of x. It will become negative f of x. 1 unit up, we always at the end here, but the q value minus 1 plus 1. Right? To write it as h of x, divide by a negative, so that would become negative there. Negative 1 plus 1 cancels, so I have negative x minus 3 all squared. So I hope you follow the process. Right? Let's look at the next problem. Alright, they say determine the inverse of h of x. So h of x we just solved is equal to negative x minus 3 all squared. Soon as they use the word inverse, my first mark will always be for swapping x and y. Alright, so I swap x and y. Get rid of the negative. I'm going to divide by the negative. So that gives me negative x, and I have y minus 3 squared. From there, to get rid of the square, I'm going to find the square root. So that square root there is plus minus square root negative x equals square root y minus 3 squared. Right? You should know that the square root of negative x has non-real roots. So we have to ensure it stays positive. That's what I enjoy about South Africa, all the different ways we can say the same things. We do this by ensuring x is negative because negative times negative is positive. So the only way to ensure that under the square root it's negative, whatever I substitute in the place of x must also be negative. So you'll see they have a restriction x less than 0. So therefore plus minus square root negative x equal y minus 3. X less than 0, and if I take negative 3 over, it becomes plus 3 equal y. X less than 0. Right, I hope you enjoy the lesson as much as I enjoy teaching it to you. Wish I could do it one-on-one, but yeah, my objective is to help as many learners as possible. All of you will have great potential, and we have to ensure all of you will get equal opportunities. Right, persevere, be disciplined, practice. It's your year. Make it count.